Computers use a system called binary. Binary, or base 2, is a number system that only uses 2 digits. From this term binary, bit, a derived term that is used to represent a 0 or a 1, which also represents off or on. Zeros representing off, while ones represent on. Computers contain millions of these ones and zeros that signal on and off, creating tasks and functions of each sequence. For example, since computers use binary or base 2 as the number system, this is how we get our values. The very first binary, using exponentiation, any number to the power of 0 equals 1. The second binary, 2 to the power of 1 equals 2. The third binary, 2 to the power of 2, meaning 2 times 2 equals 4. If this were to continue, 2 to the power of 3, meaning 2 times 2 times 2 equals 8. Now that you understand the underlying ideology and exactly how we get these decimal values, from here, we go back to the usage of ones and zeros representing on and off. For each decimal value, you would pair it with either a 1 or a 0. Here's an example. If we pair all the values with all zeros, all the values would be set to off, because zeros represent off. This means the total would be 0. In this example, the value of 1 is set to on, making the total 1. In this example, the values of 2 and 1 are set to on. 2 plus 1 equals 3. In this example, the value of 4 is set to on, making the total 4. Now, understanding this, computers do not display the values. As I mentioned before, computers only use ones and zeros, so you only see the ones and zeros. Computers usually use sets of 8 bits, also known as a byte. For example, if 4 and 1 were to be turned on, this byte, or 8 bits, would look like this. It would equal 5, because 4 plus 1 equals 5.